Okay, in this example, we're going to multiply these two expressions. X squared minus 1 divided by 3 times 1 over x minus 1. And we look to see if we can factor numerator and denominator. In this case, x squared minus 1 is the difference of two squares. And there's a property when you have 2 squared, a squared minus b squared, that can always be factored into a minus b times a plus b. So the difference of two squares can factor into the difference in the sum. So we want to apply this property to x squared minus 1. So what will x squared minus 1 factor into? It will factor into x minus 1 times x plus 1. And still we have that over 3 and times this expression here, 1 over x minus 1. And so we multiply through to get x minus 1 times x plus 1 divided by 3 times x minus 1. And then we cancel out like terms if we can, common terms. This one, x minus 1 over x minus 1, it gives us 1. And so our final answer is x plus 1 over 3. Let's take another example. In this example, we're asked to divide 2x squared minus 11x plus 5 divided by 5x minus 25, that expression, divided by 4x minus 2 over 10. So we've been doing multiplication of rational expressions. This is a division. However, when you divide fractions, remember what you do is you change this to a multiplication and you flip the term you're dividing by. So in other words, this division can be rewritten as 2x squared minus 11x plus 5 over 5x minus 25 times, this flipped, 10 over 4x minus 2. Now we factor the numerator and denominator. I can see I can factor there's a trinomial here. I can factor out a 5 here. I can factor out a 2 here. So if we do all this factoring, we end up with 2x minus 1 times x minus 5. So that's the factorization of this trinomial 2x squared minus 11x plus 5. So the factors of 2 are 2 and 1. Factors of 5 are 5 and 1. And you have to put both negatives in order to get that negative 11x in the middle. So we factored this one. The factors of 5x minus 25, we can factor out a 5 to leave us with 5 times x minus 5. This 10 stays the same. And this 4x minus 2, we factor out a 2 to give us 2 times 2x minus 1. Now, remember, you could multiply and then cancel, or you could even cancel before you multiply. Sometimes it's the same thing. It doesn't matter which order you do it in. We look for common terms, both top and bottom. Because remember, when you multiply to rational expressions, all you really do is just multiply straight across the top and bottom. So we could just cancel out terms if we see any common factors. For example, 2x minus 1 and this 2x minus 1 would cancel out because the division of those equal 1. X minus 5 divided by x minus 5 is 1, so those would cancel out. And then 5 times 2, or 5 times 2 is 10. In other words, we're going to be left with here 10 divided by 5 times 2 is 10. Well, what does that give you? That gives you 1. So this division leaves us with just 1. Now, it's really good to know how to apply these canceling out terms of multiplication, division, rational expressions. It's very useful when we start to work with units and converting from one unit system to another unit system. So let's look at an example of that.